Hey folks, okay, what I want to do now is go through and introduce Lab 2 for the course. So this one's picking up where Lab 1 left off, and we're going to go through and see what kind of fancy new features we can add, going through and basically modifying the lex and yacc code that we came up with last time. So the idea is in Lab 1, you were going through and making sure that it recognized the tokens that were supposed to be in the language. So the keywords, the operators, the symbols, and the names and numbers. And it went through to check that the tokens were strung together in a valid syntax form. So you had the rules for, a program is made up of a map, set the map size, start keyword, then a bunch of statements, then a finish, etc., etc. So what we want to do this time is to pick up from there. So you've got to get your Lab 1 working before your Lab 2 is going to work. So if there were still issues with your Lab 1, you're going to have to get those fixed. As far as Lab 2 is concerned, what we want to do is add a symbol table that's going to keep a record of all of the different AI names that we've seen, and for each of them it's going to keep track of key information about them. So what row and column of the source code file was the create statement in. On line 3 of the source code file in, column 50 or something like that, we had the create statement for this particular AI. Then it's also going to have the name of the AI stored. So in the symbol table, we'll store the name. We'll store sort of where in the source code file that name came from. And then we'll go through and store the row and column, the map row and column that the AI was declared with. So when we did that create statement, we said create it in row 17, column 12 or something like that, and the facing north, south, east, or west. So our symbol table is going to keep track of all of this information about each of the AIs that gets created. And then as we go through the program, if we see something like a move state, move Fred to so many units, it can go back and check and make sure that Fred has actually been created. And if we see a create statement, we can make sure that that's not for an AI that's already been created. So you can't create the same name twice in the program. So this is the kind of checking that we're going to add, and we're going to use a symbol table to do it. So specifically, the kinds of things we want to check are, again, make sure that we don't have any duplicate creates, so you can't create the same name multiple times. Make sure that you've created an AI before you use it, so you can't move it or turn it or print it before a create statement for it. And we'll also keep track of the map size that was generated, so you can have just a global variable for that if you like. So we'll keep track of the map size, and we'll make sure that any of the commands don't use a number that's bigger than that map size. So if the map size is 80, you don't do something like create somebody that's in row 81 or row 200 or something. Or you don't say move 200 because that's guaranteed to go off the map. So we won't worry about the runtime checking. We won't worry about things like, if they're currently in row 40 and they try and move 40, is that going to take them off the map? This is just straight checking the numbers in the create commands themselves and in the move commands themselves. So those are the 3 forms of error checking that we're going to introduce. If your program does detect an error, then it's going to generate an informative error message. You have done a duplicate create on Fred, or you've tried to use Fred in a move command before it was created. So things along those lines where we've got reasonably precise information about what's going wrong. So as far as our symbol table is concerned, again, in the symbol table, when you see a name, when you see a create statement, you're going to say, okay, I've got something I have to try and add to the symbol table. If it's already there, it's an error. If it isn't already there, then I'll go through and add, where did this create statement come from in the source code file? What's the name of the AI? And what's their map information? What's their map row and column and facing? At the end of the program, aside from the error checking, I want you to print out the contents of the symbol table. So print out the map size and print out, for each entry in the symbol table, Bob was declared on line 3 in column 26 of the source code file. Bob's starting coordinates were, row 10, column 5, facing south, something along those lines. I'm not too worried about the actual wording of it, but all of that information has to be there, clear enough to understand. So, in terms of actually accomplishing that, we're going to need to do a few things. We're going to need in the lex file, when we see something like a name or a number, in addition to just saying, in addition to just having it say, oh, I found a number, or oh, I found a name, it has to remember what name or what number and associate that with the current token. So this is where these YYL vals are going to come in. So this is a variable that's associated with each token, and we can provide information about the token once we actually see it in the source code file. So in our .lex file, as it's going through processing tokens, it's got the string, the current kind of sequence of characters for that token in a variable called ytext, basically just a null terminated character array. So if once I've seen my token, I want to figure out what integer that represents, I can use the a to I function, pass it the string, and it'll return whatever integer that character array represents. So if it was the characters 357, it'll return 357. Now, I'll talk about this bit in a moment when we get to the yacc file. So essentially, for each of the YYL vals, there's a struct named info that's got fields for the number and for the name. And so what we're going to do when we're setting up the information, the data associated with a token, is we're going to say, okay, well, go to the struct for that token and fill in the number field and fill in the name field. So at the moment, for a digit, it doesn't have a name associated with it, it just has a number, so we're figuring out the number and storing that. And I'm just going to make the name a null string, so I'm just going to throw a null terminator in that first character. That's all that's going on here. And if we're keeping track of row and columns, then we're going to look at ytext and say, well, how many characters did I read in? And that's how many characters we advanced in the column. And again, as before, we're saying, okay, I've found a token of type number. So you'll be doing this for digit. And for the names, you'll be going through and saying, well, I've got to do something similar. The number part of the field won't be relevant for a name, so you can just set it to 0 or -1 or some default value. But then you'll probably use something like string copy to copy ytext into the info.name. All right, so you can go through, and in the lex file, you're just making sure that the data associated with the token gets recorded. So the lex side of things is pretty straightforward for lab2. The interesting part is going to come in the yacc file. In the yacc file, we've got to set up the C code for our symbol table, and we're going to have the functions that we're going to write to try and add something new to the symbol table, to print the symbol table, to check and see if something already has been declared in the symbol table. So starting off in that C section up at the top, where we have our hash includes and all that kind of thing, I would suggest creating a data type for what an entry in the symbol table is going to look like. So I'm calling this symbol, for instance. Symbol is just going to be a struct that has integers for the row and column from the source code file, and let's say longs for the row and the column in the map. And I'm going to use long as the facing here, so maybe I'll use 0 for north, 1 for east, 2 for south, and 3 for west, or something like that. You don't have to do that. You could use a character for facing, just as long as you're or whatever else you like, an enumerated type for facing, as long as your code handles the way you set this up. So, and the last thing is we need a character array to hold the name. So I'm going to assume that we've actually hash defined the maximum name length up there somewhere. So, you know, maximum name length is 64 or 128 or whatever number you pick. So that tells us what kind of data we're going to associate with any entry in the symbol table. Now we actually have to create the symbol table. So the data type is going to be one of these symbol structs, and I'm going to call it sim table, and I'm just going to say, well, here's the maximum number of symbols I can support. So again, I'm going to assume that I've hash defined this up there somewhere, 100 symbols or 1,000 symbols or whatever it might be, and I'll keep track of how many entries I actually have. So it's going to be 0 in the start, and every time I insert one, I'm going to bump that up by 1 every time I successfully insert. Right? And presumably you're going to need functions to do an insert, right? Where you say, okay, well, here's the name of the AI, here's its source code file row and column, here's its map row and column, here's its facing. Please go try and insert one in the symbol table and update the number of symbols if it works. And again, I'm going to get it to return, true or false, did it work or not? Maybe I have another one that's kind of a lookup. Does this name exist in the symbol table yet? If so, return true. If not, return false. And maybe one more to go off and print the table. Now you might go through and create a whole bunch of others, but I'm going to throw prototypes for these in that declaration section up top. And then in the bottom C section, you're going to have to actually implement whatever functions you create here. So that's kind of our setup for our symbol table. The other things we need to do are to say, well, now I've said over in that lex file, I mentioned that I had this info struct that had the information I wanted to associate with a token. And I'm actually going to use this for the non-terminals in my language as well, but we'll get to that in a sec. So I'm just going to create a struct. So in this case, it's got one field that's a long for a number and another character array for a name. I should probably have hash defined a constant for that name length or used the one that I declared back up there. That would have been the intelligent thing to do. So I'm specifying this is the data that I'm going to associate with any of my tokens or in fact any of my my other non-terminals. I'm going to call it info. And again, so if you look back at what we were doing with the lex file, we said if we wanted to refer to something, we'd refer to it by yacc dot and then info, my struct name, and then whichever field we were accessing. So that's where that information is coming from. If you recall, in lab 1, we had all of our tokens were of type long. We're just changing it to a new type now. Same idea. You want to make sure that you've got all your tokens listed here. And I'm going to do the same thing with all of my non-terminals. So all I'm really doing there is changing the data type for what these things are made up of. So we've specified what kind of data we can associate with anything. And over in our lex file, we made sure we were copying the data into the YYLVAL for my numbers or my names. And now I want to go through and say, well, if I actually want to use this, so in all those grammar rules, I've just taken a couple of snippets out here to give you an idea. In all those grammar rules, if I want to look at the actual number that was associated with a specific token, so let's say I had a set map where it had the map size 80 or something like that in a semicolon. Well, when it's going through parsing this, I'll add a chunk of C code for this. So the C code is in the curly brackets, of course. And if I want to find out what that number's value actually was, this is the syntax. A little funky, but it does work. So it's $, and then the angle bracket, and then inside it's the struct and field you're accessing, so the info.number. You don't need the YYLVAL in here, and it'll yell at you if you try and use it. So for that number, I want to access info.number. Now, the 2 on the end here is specifying which of these 3 things the value is supposed to be associated with. So map size is 1, number is 2, and the semicolon is 3. We don't care about map size and semi. They don't have any useful data associated with them. We're just interested in the number field associated with that middle token. So we can go through and look up and use whatever data is associated there. And again, if the data was a character array, then we could use the same sort of thing. So for the create statement, right, for a create where it's supposed to have the name of the AI, the row number, the column number, and whatever the direction was, and then a semicolon. If I'm going to try and do an insert using that insert function I specified earlier, I want to look up the name from token 2. The row and column were the ones that we were setting up and maintaining in the lex file. the map row and the map column. Oh, I cut those out. Sorry, I had a variable declaration here. Your map row is going to be the number associated with that one. So it's going to be my info.number for 3. And my map column is going to be the number associated with this one. So it's going to be my dollar less than info.number 4. Right? And the direction is the dollar info.number for 5, right? For that 5th token. So what I'm saying is if the insert works, great, wonderful, I don't have to do anything. If it fails, then I'm going to print out a YY error message and say, you've redeclared, or possibly something else went wrong, but I'm going to assume it's a redeclaration for the moment. If the insert failed, you've redeclared whatever that name is. So the name associated with that particular token. And of course it's a string, so when I'm printing it out here, I use the %s. So this is how, in our grammar rules, we can start adding C code to check, or to build our symbol table, to check if it works, to start doing things like grabbing the map size, or in the other things, if I've got a move instruction that's got a number associated with it, I can check and see if that number is bigger than the map size. Right? So these are the kinds of things you're going to be going through and doing. Now, at the bottom, you just have to remember that all of those functions you said you were going to create back at the top, you actually go through and implement here. So you're going to have to implement the insert and the check and the print table and anything else that you've specified. And then just remember in the main routine, once it's finished, make sure you print off the symbol table. So that's pretty much the idea. Again, in terms of testing, you're going to want to add tests for things like using a name before it's been declared, redeclaring a name, using a move that's out of bounds, trying to create a name with a value, with a row or a column that's out of bounds, that kind of thing, are all things you're going to want to add to your error checking. So that's pretty much the idea. I think in terms of the mechanics, the only other thing I would mention is with that repository, when you first clone the lab2 repository, if you take a look in the lab2.lex, it's just the skeleton code, the same as you had in the very beginning of lab1. So I assume that what you're going to want to do is to copy the lab1.lex from lab1 into your lab2. So, something like copy my lab1.lex into lab2. But remember, in lab2, we want to name it lab2.lex. Right, and then something similar with our yacc file. So that way you can go through and just start working on whatever code you left off with in lab 1. However, I will leave it there for now, and yeah, we'll talk about these in the lab sessions.